Ever wonder why your phone's AI can't figure out a simple puzzle that a kid would breeze through? Like, why does it get confused by a math problem that's obvious once you see it? Well, researchers just uncovered something wild. Even the smartest AI models, like the ones powering your chatbots, still struggle with basic reasoning. Let's break down why that happens and what it means for the future of AI. So here's the thing. Large language models, or LLMs, are basically superstars at tasks like writing essays, coding, or even solving complex math problems. But when it comes to logic, like figuring out why a fridge light doesn't work or solving a classic puzzle, they trip over their own feet. Think of it like a genius who can solve a Rubik's Cube in seconds, but can't tell you why the TV remote isn't working. The researchers behind this study created a bunch of puzzles that seem easy to humans but stump AI. Take this one. If 13 purple, 15 yellow, and 17 maroon chameleons meet in pairs, can they all turn the same color? The answer? No. But if you tweak the numbers to make them all 15, suddenly the answer flips to yes. Same logic, totally different result. And guess what? The AI gets confused. Why? Because these models aren't really understanding the reasoning. They're memorizing patterns. Imagine a student who crams for a test by rote memorization, but can't apply the same concepts to a new problem. The AI might have seen similar puzzles before, so it relies on shortcuts, like pattern recognition, instead of working through the logic step by step. Here's where it gets really interesting. The team made a dataset called Unpuzzles, trivialized versions of famous puzzles. The original ones are hard, but the simplified ones, they're easier, yet the AI fails harder. Why? Because the models are so used to the original versions that they can't adapt. It's like if you changed the rules of a game you've played 1,000 times, you'd be confused too. This isn't just about AI being stupid. It's a big deal because it shows that even the best models struggle with out-of-distribution generalization, which means they can't handle tasks that are slightly different from what they've seen before. And here's the kicker. Making a task easier doesn't always make it easier for the AI. Sometimes it backfires. Let's dive into a specific example. Imagine a statement. It's not true that someone in group X has 5 apples, the obvious fix. Just say someone in X does have 5 apples. But here's the twist. When researchers tested this with an AI model, it messed up. Instead of flipping the not, it accidentally added a rule that didn't fit. Sound confusing? Let's unpack it. This is about logical negation, the fancy term for flipping a statement. If the original is not exists X, P, X, the correct answer is exists X, not P, X, but the model. It ignored that rule, like forgetting to switch off a light when you leave a room. And this isn't just a math problem. It's a big deal for AI that needs to reason, like solving puzzles or understanding stories. Let's break it down. The original statement was a negation. It's not true that someone has 5 apples. The correct answer should be someone has 5 apples. But the model didn't just flip the not. It added an extra condition like saying, someone has 5 apples and they're wearing red shoes. That's not just wrong, it's making up rules. This isn't just a fluke. The study found that even advanced models struggle with these kinds of logical flips. Why? Because they're trained on patterns, not deep understanding. They see not and think, okay, I need to reverse this, but they don't always grasp how to reverse it properly. It's like learning to drive by memorizing directions, not understanding traffic rules. And the results? Some models got it right, others, well, let's just say they gave answers that made no sense. One model, when asked to negate all ducks are green, replied, no ducks are green and also all ducks are purple. It's like the AI thought it was being clever, but it just confused everyone. Now let's look at another challenge, the counterfizz problem. Imagine a riddle. Alice has 7 apples. David has 2 more than Charlie. Bob has the same difference as David and Charlie combined. Your job. Figure out how many apples Bob has. Simple, right? But here's the twist. If the AI misinterprets more than as multiplied by, it'll spew out a wrong answer. And these tiny errors, they add up. This isn't just about apples, it's about logic. Researchers call these the building blocks of reasoning, like the rules of a game. They taught AI systems to follow steps. If A eats 5 apples, A's total decreases. If A and B swap apples, their counts switch. It's like teaching a robot to play checkers by explaining each move step by step. But here's the catch. AI doesn't understand the rules the way we do. It's following patterns, and sometimes those patterns lead to mistakes. Take this real-world test, a problem about blueberries. The AI had to track numbers while ignoring distractions, like a line saying, Thaddeus has 17 more blueberries than Zane and Artie combined. But the model missed a key detail. Thaddeus already had some blueberries from earlier. Result? It calculated Artie's total as 6 instead of 23. Ouch. Why does this happen? Because AI struggles with filtering. It's like solving a puzzle while someone keeps throwing random facts at you. Margarita has 1 blueberry. Everett's blueberries increased by 14 times. The model can't tell what's relevant. And when it gets confused, it either guesses, makes up numbers, or misses critical steps. So what's the big deal? These aren't just silly math problems. They're tests of reasoning, the same skills we use to diagnose illnesses, plan budgets, or even debate politics. If an AI can't separate the important from the absurd, it's not just flawed, it's a warning. Even the smartest systems need to master the basics first. So what does this mean for the future? It means AI is still a long way from thinking like us. But it's also a chance to improve. By understanding these gaps, researchers can build better models that actually reason, not just guess. Next time you see an AI get a simple problem wrong, remember, it's not just a glitch. It's a clue about how far we still have to go. Thanks for watching. If you want to explore more about AI's limits, hit subscribe. And let me know in the comments, what's a puzzle you think AI would never solve?